Hi, this is Tim from Tiger Astronomy. In a previous video I did a whirlwind introduction to the Reactive ASCOM library and showed how you can just quickly put together a console application to set up the classes you need and make transactions and communicate with the device and get the response back, and we showed that running. And I just briefly touched on the idea of transactions and mentioned that the whole idea of this was that you can derive your own transaction classes, and in this video I want to expand on that subject, and we will actually develop a transaction that can process sexagesimal strings. So instead of getting the right ascension value back as a string, we will actually get it back as a double, suitable directly for use in an ASCOM driver. And I think you'll start to see some of the power of the reactive extensions as we go through this. Okay, so first of all, here's the code as we left it on screen, and I'll just quickly run that to remind you what that code does. The drive system's powered up on COM1, and we're just waiting for the build. And there we go, and we get our answer back just there as basically a string. Okay, so far so good. Right, now the first thing I want to do is cheat a little bit and bring in a class from another project. It's just a little class for parsing sexagesimal strings. I could sit here and type it, but it just wastes time and you wouldn't learn much. So okay, we're just going to pull it in and fix it up. Okay, add existing item sexagesimal parser. Now it will need some fixing up because, as I said, it's come from another project, and I need to actually, do you know what, I'll leave that just as it is. That's fine. That's fine. So just a quick look through. Basically it uses a horrendous looking regular expression to parse sexagesimal values, and it's got a method to actually do the parsing, and it's got another method that just says is it valid, yes or no, returns a boolean. So it's actually conceptually quite simple. If you are that interested and you want a copy of this code, just drop me an email and I'll send you a copy. But for now we're just going to use that. So okay, back in our main program, let's add a new transaction. So we're going to add a class called sexagesimal transaction. Okay, now transactions in Reactive ASCOM all derive from an abstract base class called device transaction. They either derive directly or indirectly through another class, but one way or another there's important functionality in that base class. I'm using ReSharper to implement the missing members for me. If you don't have ReSharper, I highly recommend it. It's so useful. It's completely transformed the way I write code. Okay, now, so first of all we need a constructor which just calls into the base constructor, and observe response is declared as an abstract method in the base class, so we must override that method, and that is pretty key to how a transaction works. Before I do that though, I'm going to add a value field. Double value get, and I'm going to make the setter private because I don't want any code to be able to set that apart from this class itself. Okay, right, the next thing is to fill in the details of our overridden observe response. Now, the source that gets passed in here is the sequence of characters that comes from the channel. In this case it will be a serial port. So it's an iObservable of char, and we just get basically every character that the serial port receives, and we have to parse that or somehow process that stream of characters to pick out just the data we want. So the first thing to do is to filter that input sequence in a sensible way. So we are only interested in sexagesimal strings, so we will just basically pick out any response that contains a sexagesimal string. Here's the nice part. We're going to do it with a link comprehension query. So from response in source dot terminated strings is a extension method that is part of the Reactive ASCOM library, and it allows us to specify here which terminator character we'll be using, and it's pre-wired to work with MEAD type protocols, but we can put whatever character we want in there, and we get back an iObservable of string. So we've converted now our character stream to a string of streams, where each a stream of strings where each string is terminated with the hash character, or if you prefer pound, or my favourite octothorpe. Okay, so so far we have a sequence of strings, but we're only interested in strings that have a valid sexagesimal value in them. So we can say is valid response. I need to take the delimiters off the start and the end of the string before I feed it into my parser, otherwise the parser will get upset. So I can just trim start, and I'm going to take colon character off the front, and then I'm going to trim end and take any hash character off the end. Okay, so that's removed the protocol encapsulation, and then we want to select the response. Okay, so just think about that for a moment. We started off with a raw stream of characters from the serial port, and using a fairly understandable link query, we filtered that, we transformed it into a sequence of strings instead of a sequence of characters. We tidied it up a bit, passed it into our parser to check whether it was valid, and selected out only the entries that are in fact valid. So now we have in sexagesimal responses exactly what it suggests. We have now a sequence of sexagesimal strings. Now we need to subscribe something to that observable sequence. So that's what we're going to do next. Dot. I'm actually going to use a diagnostic function here. Again, this is built into the Reactive ASCOM library. It's a very useful little extension method, and you need to provide it with the name of the source. So this will be, I'm just going to use sexagesimal transaction as the name. That will be the thing to go with, I think. And then, having added some diagnostics into the mix, I then need to ensure I only get one result, because the input sequence from the serial port probably will never terminate. So if I don't take any action to prevent it, this sequence will just go on forever. So I can use the take one link operator, which just takes the first result and then completes the sequence. And then, having got the exact sequence I need, I can then subscribe to it. Okay, and we need to, in our subscribe, we need to just pass in OnNext, OnError, and OnCompleted delegates. Now, you can write your own and pass those in, but the three I'm passing in here are implemented in the base class. So well, actually we're going to override a couple of them shortly, but if you don't override them, they come from the base class and get a default implementation. Okay, so now I'm going to override the OnNext method because I need to do some special processing here. So we can override OnNext. All we're doing here in OnNext is, once again, I need to strip the terminators off of the received response. So I'm going to say value is the parameter that's passed in to the method. So trim start, I should probably make these constants or something. Trim end hash, we can tidy it up later. Okay, and then what we're going to do is call base.onNext, but not with value, with our slightly transformed version of it. And what base.onNext does, if I just drill into the base class, as you can see, basically this just takes the value that's passed in, wraps it in a maybe and puts it into the response field. And that's the override for OnNext done. The next thing we need to do is to override the OnCompleted method, because we need to we haven't set our value property yet, and we do that in OnCompleted because once we've completed, we know we've got a valid response and our sequence has ended, and so we're ready to have a value. So override OnCompleted. We're going to make sure that we got a response. Now, response is wrapped in a class called maybe, which again is part of Reactive ASCOM, and I really hate dealing with nulls. They are so much problem in code, and so I always avoid returning a null if I possibly can. And so what a maybe does is it represents something that can maybe have a value or maybe not, and then it's implemented as a collection that's got 0 or 1 elements in it. So being a collection, you can query it with link, so you can just say response.any, and that will return a boolean true if there is any elements in the collection. So if response.any, and I'm actually doing a lot of duplicate checking here, but it's probably worth it. We get the response.single, gets you the single member of the collection. So if there is a response and it's valid, a valid sexagesimal string, then we set value equals parser.parse response.single. Lovely. Okay. So that sets our value to a double. Sexagesimal parser.parse returns a double. Yes. And that's it. That's all we need to do. We need to call base.onCompleted at the end. This is critical because what this does is it actually clears the failed flag and it calls signal completion, which kind of unblocks any waiting threads. Okay, so save that. Okay, that's our transaction. So we can now use that in our program. So instead of here having a terminated string transaction, let's just duplicate the line. Var and we need to provide it with the command string, and again we can specify timeout because that comes from the base class, so it's inherited. Why don't I copy that? Okay, so there we go. Now, tell you what, let's call it RA transaction. There we go. Now we haven't got any errors. Now when we write out the value here, we should actually get a double rather than a string. And just to emphasize the difference, response string, and okay, alright, let's run that. We have a response 23, 26, 24, and we get write ascension as a double value 23.44. Okay, so hopefully you can start to see the power now of what this is all about. Okay, one more thing I just want to have a go at before I sign off. Now that we've got this transaction, we can use it in all sorts of places. So okay, let's define a couple of other transactions. So let's have a dec transaction, and that's get declination. And while we're at it, here we go. Now let's commit all these transactions in one go. Now, you may remember I mentioned that Reactive ASCOM makes guarantees about sequencing, and the guarantee is these transactions will execute in the order they're committed. So that is the order the transactions will execute in. So we can wait for the transactions in reverse order if we like. We can wait for the azimuth, we can wait for the altitude, we can wait for the dec, and we can wait for the RA in reverse order, and those transactions will complete in the order they were committed no matter what we do. So if I actually just take the error handling out of here because it's just getting in the way now. Okay, so we've committed the 4 transactions all in a heap. We've waited for them in reverse order, we've written them out in the correct order again. I have no worries about that, that's gonna work, so let's try it. And away we go, loads of output. Right ascension, declination, altitude and azimuth. Okay, so hopefully you can see how quickly, once you start building up a few simple transactions, you can very quickly then begin to implement your protocol, and all the while enjoying the guarantees of correct sequencing and thread safety. Okay, so I hope that was all clear. Do let me know if you have any questions. This is Tim Long from Tiger Astronomy. Thank you for listening, and goodbye.